Good afternoon, dear students. How are you? I'm fine, and I hope you're all good. Okay, yesterday we learned some thermodynamic processes like reversible and irreversible process. So, what is reversible and irreversible process we completed. Then we have to start from the next process, adiabatic process. Okay, so what is reversible process? You can produce or you can retain the reactant from product. Okay, and what is irreversible process? Irreversible process means it is opposite to the reversible process. So we can in reversible process we can produce reactant from the product. So in the irreversible process, what will happen? We can't produce the reactant from the product. Okay, so that should be the reversible process. So first one, reversible process. Second, this is in equilibrium state. That not possible in equilibrium state. Okay, it did not exhibit in equilibrium state. Okay, so are you clear about this reversible process and irreversible process? The next one, third one, we are going to see adiabatic process. What's that? Adiabatic process. It is also a thermodynamic process and it is different from the reversible and irreversible process. So what is going on in the adiabatic process? In adiabatic process, we will take here one term is Q. Okay, so adiabatic process we will denote or take here one term is Q. Q means what? In this chapter we will denote Q is heat. What's that? Heat. Okay, you have to remember Q means heat. So take in the adiabatic process. Throughout the process, if we take one process reacting to reactant to produce one product. Okay, so reactants produce one product. Okay, now consider this is one reaction, cold reaction. Throughout this reaction, temperature or heat energy of this reaction, okay, heat of this reaction, it's not exchange the heat. Okay, no exchange in heat, no exchange of heat in a process. Okay, no exchange of heat means what? Q. Okay, so no exchange of heat in a process, so that process is known as adiabatic process. Is it a possible one? Yes, it is a possible one. How? Where it is a possible one? In the isolated system. So in isolated system, it is possible in isolated system. What is the characteristic of isolated system? What is isolated system? If there is no change in the heat of or there is no flow of heat from system to surrounding and from surrounding to system. You can take a thermoflask. So thermoflask is the example for isolated system. So you can observe that there is no heat change in this thermoflask. Why? Because if thermoflask is fully closed, then there is no heat change. That means inside the water or milk which is filled in the thermoflask, it's not released its heat into the surrounding, and there is no change or transformation of heat from outside to inside liquid of the thermoflask. Okay, so that is isolated system. So you can take an example for the adiabatic process. For adiabatic process, you can take an example isolated system, one thermoflask. Okay, so in the thermoflask there is no exchange of heat. So what is the definition for the adiabatic process? Adiabatic process means there is no exchange of heat between a system and surrounding throughout this process. Throughout this process there is no exchange of heat. Heat we denote here Q. In the whole chapter, in this chapter, we will denote Q is heat. Okay, don't forget this. Q means heat. So you can consider the third process is an adiabatic process. In adiabatic process, we use one term is Q, that means heat. So what is adiabatic process? It is defined as one in which there is no exchange of heat, that means Q, between system and surrounding during this process. During this process, there is no exchange of heat in system between the system and surrounding, between system and surrounding. So thermoflask, liquid. So it's a closed one, thermoflask. So there is no exchange. It is not possible. Okay, so because of this, the isolated system, it is not possible to exchange heat from system to surrounding, surrounding to system. So no exchange of heat between system and surrounding, between system and surrounding. So adiabatic process, throughout the process, Q is equal to 0. So the process, there is no flow of heat from outside to inside, inside to outside. That process is known as adiabatic process. So for example, isolated system means it is a thermoflask. In adiabatic process, in one process, if the process is work is done by the system, okay, in an adiabatic process, work done by the system, then the system temperature is decreases. So you can take one system. Now open this. If the adiabatic process, if the system is done, the work done, okay, if work is done by the system means system releasing by system, okay. Work done by system. Work done by system, then system releasing heat to the surrounding, okay. Work done by the system means the system, the temperature of the system, from that temperature is releasing to the outside. It is releasing, okay, it is releasing to the surrounding. So that's why the temperature of a system can, there is a possibility to decrease. So if this work is done by the system in adiabatic process, then what will be the result of temperature? It is decreasing the temperature. It is decreasing the temperature. If maybe in an adiabatic process, work on the system, okay, work done on the system. On the system means what? Surrounding is applying, or it may be the reason of the temperature variation. So the work done on the system. So in that system, this work is done by the surrounding, not by system, by surrounding. That means it is on the system. Work is done on the system. Then the work, that means work is on the work done by work done on the system means on the system means what? Surrounding applying some temperature into the system. So it's increasing the temperature. It is increasing the temperature. Okay. So this is only the work done by the system and work done on the system. Don't confuse this two because it is important to ask the one word questions. It is important in this one in one word question. So work done by the system and work done on the system. What is the temperature variation? You should understand and write. Okay. So if maybe the possibility of adiabatic process, work done by the system and work done on the system, these two variations. But actually adiabatic process means there is no exchange of heat with its surrounding. System cannot exchange heat with its surrounding. Okay, so so for an adiabatic process, for an adiabatic process, for an adiabatic process, Q is equal to 0. What is Q is equal to 0? Heat. That means no heat exchange with between the system and surrounding. So no heat exchange means the heat change will be 0. So Q is equal to 0 for adiabatic process. Next one, fourth one is isothermal process. So what is the next thermodynamic process? It is isothermal process. Take one thermodynamic process, reactant, convert into products. Reactants convert into product. In this process, in the initial stage to final stage. What is final stage? What is initial stage? Reactant which is reacting together, that is initial stage. And product, finally the reaction is produce some product, some chemicals or compound. It is a final step. So throughout this process, there is no change in temperature of a system. Okay, there is no change in the temperature of a system, or you can write that the temperature of a system is constant during the initial state to the final stage of a reactant of a reaction. Okay, so what is isothermal process? Isothermal process means it is defined as the temperature of a system is remain constant. Okay, remains constant during what? During initial stage to the final stage of a reaction. During from its initial to final stage of a reaction. So do you understand this? What is isothermal process? Isothermal process. Now you heated two gas compound and they produce one product. Okay, one product. Now you can observe the temperature in the initial stage when they react together and observe the temperature in the final stage. That means they produce the product. So if the temperature is constant, it is same. Okay, so the what temperature is observed in the reaction which is start, and what temperature is observed in the reaction which is end at the end of this production of this product. Okay, so that is the final stage. So when the observation of this temperature from this reaction is, if it is the same, if it is same means what, the throughout this process the temperature is constant. We can say the temperature is constant throughout the process, because in the initial stage if you observe 50 degree, and the final stage if you observe 50 degree, same 50 degree, then you can say this process, it is a isothermal process. That means there is no change in the temperature. There is no change in the temperature, or the temperature is remain constant. It's remain constant. You should remember isothermal. Thermal means T is indicating temperature. Okay, remember like that. T is temperature, isothermal. T is temperature. So temperature remain constant in isothermal process. So in this process, throughout the process, isothermal process, if maybe the exchange with the heat, exchange with the temperature exchange with the system and surrounding, okay, between the system and surrounding, if maybe it is a possible one in the isothermal process. Still, if maybe the temperature is constant in the initial to the final stage, if they are applying the heat into the system, or it is releasing the heat into the system, it's not a matter in this, but the concern for the temperature from the initial to the final stage, if it is same, then you can say this whole process is an isothermal process. So isothermal process for an isothermal process, if you write that, for an isothermal process, dT is equal to 0. T means temperature. What is dT? Difference in temperature is 0 in the isothermal process. What is isothermal process? Difference in temperature is equal to 0 is defining as it is an isothermal process. So if you denote that dT is equal to 0, then that is isothermal process. So dT means what? No change in temperature. So D means change or difference. What you written near to the D, it is T. Okay, so T is denoting temperature. If you write dP, then difference in pressure. Okay, so you here you consider in the isothermal process, it is temperature. So difference in temperature or change in temperature throughout this process, it is constant, so there is no change. If you find any change in the initial stage, it may be 50, then the final stage it is maybe 60. Then if you subtract that one, you will get 10. This is difference in temperature, you can write. If maybe the other reaction, okay, but in the isothermal process there is difference in temperature is equal to 0. That means in the initial stage and the final stage you will get the same temperatures. Throughout the process you will get the same temperature. So the constant temperature throughout the process, it is denoting dT is equal to 0. Equal to 0 means the change. Okay, you should understand dT means what? Change or difference in temperature in the isothermal process, it is 0. That means there is no difference in the temperature. Okay, do you understand? Okay, we can move to the next thermodynamic process. Fifth one, it is isobaric process. What's that? Isobaric process. Isobaric process is also one of the thermodynamic process, and here throughout the process from the initial to the final stage, Pressure of a system is remaining constant. In the isothermal reaction, what is the constant? In the process, what is constant? Temperature is constant. But in isobaric process, what is constant? Pressure. Okay. This is P. Isobaric process P. Okay. Here it is B, but you remember like that, it is P. Okay. Isobaric process P. Pressure is constant. So what is isobaric process? It is defined as the pressure of the pressure of the system, it remains constant. Pressure of the system remains constant during initial to final stage to its final stage. That means okay, from initial stage to the final stage, pressure of a system is remaining constant. So if you measure pressure of a system in the initial, when you start the reaction, you can mark or note the pressure of the system. Then mark the system up to the pressure, mark the pressure up to the system reach the product. Then the final product production also you note the pressure. You will get the pressure of the system which is absorbed from that process. It is same. Okay. If all the pressure, all the stages, the pressure of the system is same, then that process, it should be a isobaric process. Okay. That process is named that isobaric process. So how to denote that isobaric process? For an isobaric process, which one is constant? Pressure is constant. So write here pressure constant. So pressure constant means how to write? Difference in pressure, difference or change in pressure. Okay, here you can say this is difference in pressure. Any difference in the pressure? No, there is no difference in the pressure from initial to the final stage. So it is 0. So what is the condition for the isobaric process? What is the mathematical condition or the condition for isobaric process? Pressure should be constant throughout the initial to the final stage of the process, and you can write that condition dP is equal to 0. It is denoting that isobaric process. dP is equal to 0. So there is no change in pressure of the whole system. Next process is isochoric process. It is also one of the thermodynamic process. In isochoric process, it is also the in here also you have to take one constant, that is volume. Okay, isochoric process means here we took the constant is volume, constant volume. When you move from reactant to the product of the of a reaction, reactants to products of a reactant, throughout this reaction, the volume which is taken from which is used for the reactant is produced into the product volume is same. Okay, it is same. Volume is same. When you measure that volume of the reactant is always equal with the volume of product, that type of product name is known as isochoric process. It is known as isochoric process. So what is the condition for isochoric process? Is like the previous one. For an isochoric process, what is constant? Volume is constant. So how to write? dV is equal to 0. Why you write this dV is equal to 0? Difference in volume is equal to 0. Is there any difference? If there is any difference, then you can write the value of that difference, but there is no difference in the volume, so dV is equal to 0. Then last and final thermodynamic process is 7th one, cyclic process. In the isochoric process, we have one example, that is combustion, the bomb calorimeter, combustion of fuel, combustion in bomb calorimeter. How much fuel we've used in the bomb calorimeter, it is one measurement of isothermal process, thermodynamic process. So that is one example, bomb calorimeter. Bomb calorimeter. Okay, this is one example for this isochoric process. Then cyclic process means, cyclic process, it is like one cycle. Okay, one cycle. When a system is starting one process and it is end at the start of that process, then that is known as cyclic process. So you know that after completing one series of changes, then again it is retain the initial stage of that cycle. That is that type of process is known as cyclic process. So when a system returns to its original stage, so when a system is returned to its original stage after completing many stage or many changes of that one series, okay, so of that one series, so when it complete many changes in that series, again it return into the original state of that cycle is known as cyclic process. So that complete one is known as cyclic process. Then you can write for the mathematical one, for cyclic process, for a cyclic process, difference in internal energy is equal to 0. Difference in enthalpy is also is equal to 0. Then difference in pressure is equal to 0. Difference in volume is equal to 0. Difference in temperature is equal to 0. That means what? From initial, measure the initial stage when it is started. Okay, when the cycle process is starting. Then after completing and reach the same point, to complete this all the changes, then again measure this internal energy, temperature, pressure, volume, everything for that reached one. Okay, for that reached or the complete cycle. Then you will take, you cannot take any changes through that. So that type of process is known as cyclic process. So in the cyclic process, there is no change in internal energy, no change in enthalpy, no change in pressure, volume or temperature. Okay. Okay students, take page number 190. Write there, what is adiabatic process? What is adiabatic process? Mark this from here to here and this also. And what is isothermal process? Up to here you mark it. Then write here, this process, or this is called isothermal process. Then again the condition. Then what is isobaric process? Full to here. What is isochoric process? Here to during the final stage. Then this line. Then cyclic process, full. Okay, study this these questions. Okay students, thank you.